remember we did touch on this last lesson. Mutually exclusive events mean that the two things have nothing in common, no overlap. They are exclusive, okay? They don't have anything in common. That would mean, there's a diagram of it there for you, by the way. So we have these, if in our Venn diagram, it would mean those circles don't overlap at all because they have nothing in common. That would mean if I wanted to find the probability of A, what does that upside down U thing mean? What is it? And, good. So if I want the probability of A and B, just testing you, that's usually the overlapping section, isn't it? There is no overlapping section for mutually exclusive, which means that that probability is always going to be 0. Okay? That's rule number 1. If I wanted to find, can you remember what this symbol is? Or, good. Probability of A or B, that is normally when we add the circles together with their overlapping section. But because there is no overlapping section, it's just adding the two circles together. The probability of A plus the probability of B. That's what it is to be the probability of A or B. Right? Okay, so hopefully those formulas make a bit of sense.
So it would be the same answer.
Yeah, so if you knew the probability of A and you knew the probability of B, then the probability of A and B, you just have to add them together. Probably A or B. All right, the non-mutually exclusive. That's our much more common Venn diagram that we have here, where we have our overlapping section. They're not mutually exclusive, meaning that they have an overlap. Okay, so if I want to find the probability of A or B, remember we add together the parts in the circle. Shh, girls. But if you're doing this as a formula, if I went the probability of A, that would be that whole circle. I'll colour it in. I'm doing that whole circle. Come on. That whole circle there is the probability of A, except for it's not colouring in my highlighted section. That's a bit weird. Let's try a different pen. That section, that works. There we go. Okay, so that whole circle there, that's the probability of A. Then I want to add together the probability of B, which means I'm doing that whole circle there. Can you see what the problem is?
Yes.
I have counted the overlapping section twice. Probability of A plus probability of B means I've added that middle section, I've coloured it in twice. It's green and it's blue. You don't want to count them twice, okay? So that's why you have to then subtract off one lot of your overlapping section. So the formula becomes probability of A plus probability of B minus the probability of A and B. Okay, because you don't want to count that overlapping section twice. Now that formula, I know it's a little bit unusual at first to get used to, but you do need to be able to use it. And we're going to be using it in some of the examples today. All right, question time. Examples. Number 1. No, listen, don't talk. Cards questions. We did one of these the other day. A card is selected from a standard deck of 52 playing cards. There's 4 suits and no jokers. Let A, I'm going to make that pink. A is the event that the card is a club. And B is going to be the event that it is an ace. Okay, so they're the two things I'm looking for. So the first thing, questions down here. A, part 1. What does the little n stand for? Number. I want the number of things that are in A. A is the events that it is a club. The pink ones. Here they are. There's all my clubs. How many are there? 13. Not probability, just number. So because it says number, we want 13 because there's 13 clubs. Part 2. How many of them, the number of things that are B. Remember that B is the blue ones, that they are an ace. So here they are. There's my aces. How many of them are there? 4. Okay. Number 3. number of, see that little dash? Not A. So A is my pink ones. Here they are up here. So not A is these 3 rows here. How many?
39.
39. Too easy. And part 4, the number of A and B. And mean it has to be both. Look at the bits that I've highlighted. How many cards are both A and B?
1.
Only that one. It's the only one that's both pink and blue. Right? It's the and. It's the overlapping section. There is only one card. Okay? Part B, all these now change to P's. So now we're doing probability. Probability of A. Well, we actually worked out the number of A already, remember? There was 13 things in A. That's all my pink ones. So I now want it as a probability, which means 13 out of my total, which is 52, which we, of course, simplify to be a quarter. Probability of B. B is my aces. There are 4 aces out of 52, which simplifies to be 1 in 13. Yeah. Part 3, probability of not A. Now the good thing is these kind of follow from these ones. We've already counted them here. We're just writing as probabilities. So not A was the 39, so it was these 3 rows, and we put that out of 52. And that simplifies to 3 quarters. And finally, the probability of A and B. The and is the one that's both, so it's 1 out of 52. So that was pretty easy once we'd already counted all the number in part A. All right, parts C and D on the next page are also to do, it is part C and D of the same question. It's following on, it's still about those cards, right? It says to find the probability of A or B. A or B. Now, just for practice, remember this formula back here? I have a formula, probability of A or B. It is equal to the probability of A plus the probability of B minus the probability of A and B. Just because that's a new formula, you can do it from the diagram, which is what you did. But let's practice with that formula because it's a new one. So let's write that formula down. A, probability of A or B is going to be equal to the probability of A plus the probability of B minus the probability of A and B. We already know what 2 out of those 3 things are. The probability of A, look back to part B. What was the probability of A? 1 out of 4. Okay, I'll show you right there. Probability of A, we worked it out. It was a quarter. Okay, the second one is the one that we haven't worked out, but we can work it out. It's not too hard to do. The probability of B, oh no, we did do it, sorry. We did work it out. Here it is. Probability of B is 1 out of 13. And we minus the probability of A and B, which is
1 over 52.
the 1 over 52. The overlapping section. And then you just type all that in your calculator and you get 4 out of 13. Now, I just really want to introduce that formula to you. You can, of course, do that from your diagram. If I ask you for the probability of A or B, it means I want to count up all the cards that I've highlighted there. Just don't count that one twice, right? So we've got 13, 14, 15, 16 out of 52, which simplifies to 4 out of 13. Okay, so you can do that one from the diagram, but not all of them. You can do that. Part D. Find the probability that the card is an ace or not a club. Okay, let's look at that. Let's do this one from our diagram. Find the probability that it is an ace. I really kind of in a different color here because it's not to do with those anymore. Let's get rid of that. So probability that's an ace or not a club. Means not a club would be these ones. How many cards have I just highlighted? 40 out of 52. Okay, so that's it. It is 40 out of 52, which simplifies to be 10 out of 13. Yes? That one?
No.
The one above?
C.
Above C, yeah, that one.
Thank you.
Right, I'll put it there so I can start reading the next one.
Yeah.
All right, question 2. This is our last question down here. This is a new, completely, not about the cards, completely separate question. 2 events A and B are such that the probability of A is 0.4 and the probability of B is 0.6. Probability of A or B is 0.85. Okay, we don't even know what A and B is, but it's giving me all those probabilities. Find. Part A, we want to find the probability of A and B. Now, we have got A, B, A or B, and A and B. They're all combined somewhere in a nice convenient formula, aren't they? Yes. Okay, so we can use that formula again. The formula was, I'll write the full thing down, probability of A or B is equal to probability of A plus probability of B minus the probability of A and B. Okay, now let's sub in the things that we were told. The probability of A or B was 0.85. That was the first one on the left side of the equal sign. That equals the probability of A, we are told, is 0.4 plus the probability of B, which we're told is 0.6, and then minus probability of A and B. That's the only thing I don't know in that formula, and it's the thing that I want to find, which is kind of convenient. Okay, so I just need to rearrange it to find out what it is. First of all, what is 0.4 plus 0.6? 1. So we've got 0.85 equals 1 minus probability of A and B. Then, let's do a little switcheroo here. I want to add that across to that side to make it positive. You can see how it's negative there. You'd add that across there and you subtract the 0.85 back to the other side. Can I do that in one move? Is that going to be all right with everybody? Who said no? Did someone say no? It's not okay? Oh, it is fine. You're just saying no to mess with me. Probability of A and B is equal to 1 minus the 0.85, which is 0.15.
That's what I want.
Very good. Yes, got it? All right, look out for this. Remember that formula? It's always on the test. You need to know how to use that by subbing in values like that. One more bit. Every year, I don't really know why, every year this question, not the exact same question, but one very similar to this, stumps people, so many people on the test nearly every year.
0?
Everybody concentrate really hard. Do you remember yesterday when we took, was it yesterday? Probability of not A and not B. Okay, let's think, Charlie. That time. Oh, it was Haley, was it? Oh, sorry, Charlie. Okay, here's my Venn diagram so we can get a visual on this. If something is not A, it cannot be A and it cannot be B. It was and, which means it cannot be either of those two things. What part of the Venn diagram can I have? Oh,
The outside.
the outside. I can't have A, I can't have B. That also takes out the middle section. So that means I'm wanting the outside part of that Venn diagram. Okay? So the formula for this is that the probability of not A and not B is the same as the probability of A or B, not any of it. Okay, so that symbol means A or B, which usually means those three parts added together. And the line going over all of it means that I don't want any of those three bits. Do you see how that's the same thing?
Oh, yeah.
So, what was my probability of A or B? Of not A or B, sorry. It is 0.85, correct? So A or B was my 0.85 up here. So not that is going to be 1 minus. Remember your complementary rules? If I know that A or B is the 0.85, then not that is going to be 1 minus it, because 1 is the total of all probabilities. So that comes back to be the 0.15. Again, a bit of a coincidence, it's the same as that other one.
Why is it always 1?
Because probabilities, unless they're percentages, probabilities always add up to 1. So a complement of something is always 1 minus, isn't it? Yeah?
Yeah.
Yeah? So when I roll a 6 on a dice, the probability is 1 out of 6. The not rolling a 6 on a dice is 5 out of 6. It's 1 minus that. Yeah? Okay, so let's go through that again. Probability of not A and not B is the same as not any of those circles there. Those circles are this one, 0.85. It's the A or B. So it's going to be 1 minus that number there. Okay, maybe you don't even need the formula. So it's just not that bit. I just want 1 minus that. Okay, does that make sense? Barely. Definitely going to be on your test, so make sure it does make sense. So that is 3C.
Probably that is meant to be a little easy topic. This is like